Hey everybody, how you doing? I hope you're having a great weekend or a happy Monday. And we're going to get into something new and weird. We're going to take one more look. We did a lot with parabolas, with x squared equations. Um, we did all those transformations. We solved them. We've solved so many x squared equations, the completing the squares, all that beautiful stuff. But none of that was the formal definition. The formal definition of a parabola, I'll talk about it in class, but this right here is kind of the shortness of it. If your parabola goes up or down, you're used to a vertex form that looks like this. And then if you solve that equation and you manipulate it algebraically, you could get it to look like this, and this would be a conic form. And I explained this, I'll explain this in class on Monday, how to get from vertex form to conic form, and also talk more then about what conic form does for you. But a friendly reminder, you got the directrix here, which is this dotted line that's not part of the parabola. You have the vertex, which is at HK. You have the focus right here, and the distance from the focus to the vertex and the distance from the vertex to the directrix is a distance of p. Hey, that's what I said right here. Distance from vertex to the focus and the directrix. Now, parabolas can go up and down. They can also go left and right. If you have an x equals y squared type graph, this would be vertex form of a y squared variety. Because the y is being squared and not the x squared, the graph would ultimately look like this. If you got it into conic form, it would look like this. The vertex would be at HK, and then the distance of P from the vertex leads you to both the focus and the directrix. Alright, so in these three examples I have, first three examples, I want to write an equation for the given parabola, and in this case I have a directrix of y equals 6. I'm going to draw that in. The directrix is this dotted line, and the focus is at 5, 2. Now, because let's see, we have a horizontal directrix, so this is going to be an up or down parabola, so I'm going to be using this form of the equation. And I know that the vertex is halfway in between the focus and the directrix. This has a y-coordinate, drawing it way down here. My focus has a y-coordinate of 2, whereas my directrix has a y-coordinate of 6. That means that the vertex must be right here, and this point must be same x-coordinate, 5, and then the y-coordinate, halfway in between 2 and 6, is 4. And if this distance between from the focus to the vertex is this is a distance of 2, and if you look up here, the distance from my vertex to my directrix is a distance of 2. So that is my p here is 2. All right. So so the p is equal to 2. The vertex is 5, 4. So now I can use this equation right here and plug this information into it. 4 times 2 times y minus the k, which is 4, equals x minus the h of the vertex, 5, quantity squared. Now, the answer needs to be in vertex form, so you just do a little bit of algebra. 4 times 2 is 8. That gives me y minus 4 here equals x minus 5 quantity squared. Divide both sides by 8, so y minus 4 equals x minus 5 quantity squared over 8. Then add 4 to both sides, so you end up having y equals, all this squared divided by 8, that's the same thing as 1/8 parentheses x minus 5 quantity squared, a vertical dilation by a factor of 8. And then you add 4 to both sides, so plus 4. All right, that's example 1. Example 2. In example 2, they give me the vertex and the focus. Okay, so if I think about this, the focus, I'll start with the vertex. The vertex is at 10, -4. And the focus, oh wait a minute, I just realized I must have made a mistake here on my previous problem. Because the directrix was like this and the focus was like this, that guaranteed that my parabola was going to go down, which would actually make my answer negative. -1/8. So you do need to consider whether your graph goes up or down, and then work that in. I'm surprised it didn't show up in my math somewhere. Maybe my p I should have used -2. But this works as well. Up, positive, down, negative. All right, back to number 2. Sorry about that. If my vertex is at 10, -4, and my focus is at 10, +2, as I mentioned from page 1, if you've got the focus and the vertex, I'm getting confused. I'm going to label this a V and that an F. If I have the focus and the vertex, the distance from here to here, distance of 6, that's the same distance that's going to go down to the directrix, which would be at y equals, if you went down 6, it would be y equals -10. But using this information, you know that the distance from the focus to the vertex is a distance of 6, so p is equal to 6. The vertex is at 10, -4. So you could use that information to come up with an equation. Because this is the directrix and this is the focus here and the vertex is here, that means it's going to be an upward facing parabola. So at the end of the day, when I get to the problem, it should be positive because it's upward facing. But if I use this equation right here, this 4p1, I have 4 times 6 times y minus k, so y plus 4 equals x minus 10 quantity squared. All right, algebra. 24 y plus 4 equals x minus 10 quantity squared. Divide both sides by 24. So y plus 4 equals x minus 10 quantity squared over 24. Subtract 4 from both sides. So I end up with 1 over 24 times x minus 10 quantity squared minus 4. And this upward facing parabola, so my answer should be positive. All right, number 3. Number 3, I have the directrix equals x equals 4. That is a vertical line. So my directrix is a vertical line, and my focus is at 10, 2. So if this has an x value of 4, the point 10, 2 would actually want to be way over here on the right. And if this is the focus, what do we know from earlier? That the focus halfway in between the directrix and the focus is where the vertex hangs out, and then that distance in between all of those would be my p. So halfway in between here and here, let's see, if this is at x equals 4, so this is 4, 2, and this point is 10, 2, that means that this point right here must be 7, 2, and that's my vertex. And your graph always points away from your directrix, so it would go like that. And the distance from here, from the vertex to the focus, is a distance of 3, as is the distance from the directrix to the vertex. These problems are tricky, so I get a 3 there. And now I'm going to be using the y squared version of the equation because it's going side to side, this one, and p is equal to 3. The vertex is at 7, 2. So using this equation, I have 3 times 2 times x minus h, so that's 7, equals y minus the 2, y minus k, so y minus 2 quantity squared. And then solve it out the same way that we've done the others. 6 times x minus 7 equals y minus 2 squared. Divide both sides by 6. Or as I'm going to think about it in this case, multiply both sides by 1 over 6. So x minus 7 equals 1 over 6 times y minus 2 quantity squared, which means your final answer is x equals 1 over 6 parentheses y minus 2 quantity squared plus 7. All right. So that is building an equation when you're given information about the graph. And now there's other ones too. It's basically going to start like this, that the directrix is at x equals 4 and the focus is at 10, 2. And your job is to sketch a complete graph of that problem. And I actually already did most of that work with my setup. Actually, now that I think about it, this is a complete graph. A complete graph needs to include a labeled directrix, which is x equals 4. It needs to have the labeled focus, which is 10, 2. It needs to have the labeled vertex, which is at 7, 2. And then it needs to have the drawn graph. And that is a formal graph using the definition. That's not a very good parabola. I can do better than that. I'm going to do better. Vertical line, x equals 4. This point's at 10, 2. This point is at 7, 2. And then I'm going to cheat here. I'm better at doing my parabola if I'm going up, because that's kind of what I'm used to doing. And then I turn it sideways. Yes! Look at how much better that looks. Go Elliot. Yes, so to draw a complete graph at this stage of the game using the formal definition, you need to include the focus, the directrix, and the vertex in your graph. And as long as you have those 3 things, you have a complete graph. Alright, those are parabolic conics. I hope you found this lesson enjoyable. And if you have any questions, you should stop and ask me those questions before starting in on that homework. I hope you have a good day. Talk to you later. Bye-bye.